All right. Um, I had this all done. Then I realized that I didn't have audio on part of the video. It looks like I've got audio now. So you're also going to be spared me cutting, stripping, and crimping wires. That's kind of boring. But this enclosure, um, it's from Elcom. Not my favorite to work with, but it does the job. It's 20 inches tall, 16 inches wide, and supposedly it's 11 inches deep. By the time you add the back plate and the din rail, we lose some of our depth, which is, you know, sad, but we can deal with it. So some of the components that I'm working with, uh, these tan component din rail, these are spacers slash locks. When you put them on here, you can tighten the screws down, which will lock them in place and keep things from sliding around if we can get them on there. They are tight. All right, so we got a spacer slash lock at the end that'll keep things from sliding around. And this cabinet here has got built-in AC distribution. Um, the cooling fans, there's a heater block behind the back plate. And in this particular cabinet, we're just going to plug our power supply into the provided outlet. In other cabinets, we might bring the AC straight into a circuit breaker of sorts as our main disconnect for the entire cabinet. That will disconnect the AC from the power supply so that we can work on the rest of the system. So here's our power supply combination. We have a 24 volt, 240 watt power supply and a 24 volt, 40 amp UPS module. This can handle up to 960 watts and will take care of charging and maintaining the batteries and providing power from the batteries in the event of a power outage. On the top of these modules, we're bonding the ground to them. The ground will be bonded through the DIN rail, through mechanical connectivity, but we also want to go ahead and make sure that we're well grounded. So we went ahead and put a short piece of ground wire to connect these two modules. So if you have to replace one of these, just be aware that they should have a wire up top. So that's going to snap in there, and that's going to snap in. Well, sometimes I need a little help with the latch. Those are secure. AC power, we're just using a cannibalized PC power cord that will plug right in there. Extra length, not going to hurt anything. Typically, if you're building this, you can cut that down quite short because you just don't need that much wire. That much. All right. Put another spacer in here. That'll lock that down. And again, it just keeps things from sliding around, but it also provides us with some space to get our screwdriver into here. You know, if it's closer, you can kind of block access unless you have a really long bladed screwdriver. All right, so this breaker or switch is going to be our battery disconnect switch. And we're going to be jumped right over to here. These are terminal blocks. They do have a bridge clip in them to connect them. You can actually connect a lot of these together. Here's the neutral, which will have 3 blocks altogether for 6 terminal positions. So go ahead and mount that in here. And these are the grounding blocks. On the back side, they will provide a mechanical connection contact with the DIN rail to help keep everything grounded. And you may or may not want to run a ground wire from your up here down to this terminal block. I don't have enough ground wire. That's the only piece I have. I'm not sure why I didn't grab some. It will be fixed before this goes out into the field. So we have our positive terminal block, which is going to be only for batteries. And we have a neutral terminal block, which will be for everything in the box. And then, oh, I forgot. We need a spacer there. And real quick, here's why you need a spacer. You can barely get a screwdriver in there and it actually moves that terminal block. So we're going to insert a spacer. And sometimes a flat bladed screwdriver will help get those in there. Now we can put our positive terminal block, our grounding terminal blocks, and our, forgot to put this on here, just a little shield. These contacts are exposed on one side. So we just add a shield to keep everything safe. Now we'll finish that row of terminal blocks up with another spacer. And then here we have our disconnect for our equipment. And finally, one last spacer. You may want to come back on these spacers and just tighten them down just a little tiny bit. Sometimes they're a little loose, but they are adjustable. But you can see it'll wiggle, but it's not going anywhere. All right, the equipment itself is, in this case, going to be a 12-port Natonic switch. You can see we can slide that around. We could put a locker spacer over here. Might not be a bad idea, but that gives us some room. We could even add have room here for a couple more breakers. If we really needed to, we could also add a second piece of DIN rail up here, put additional breakers for additional power distribution. But if that was necessary, we would probably need a much larger cabinet than this. So let me get this switch back out of here temporarily, get it out of the way, and let's start wiring these things up. Take care of the easy stuff first. I've already got these terminated. These are battery leads. And those are just going to slide right into our terminal blocks. It's a little tight. There we go. Do not over tighten these. You want them nice and snug, but not really torqued down. And again, a little bit tight there. There we go. Get a little tug, make sure we're secure, and we are. Get our neutrals or returns taken care of. Oop, did not get that in there good. And that's why we give them a nice tug. If they're loose, you can still get some electrical contact enough to run it. But if a loose wire's in there, it could heat up. It could arc and eventually fail, possibly even starting a small fire. So you want to make sure these are in there properly and good and snug. think I got it that time. Yep, we're good. And last battery lead. Loosen that up. Loosen it up, and then we tighten it up. Lock it in there. All right, our battery leads are good. Go ahead and we're going to connect the other side of the battery block. I think that's in there. No, it's not in there. How about that? Try it again. And I'm kind of working blind for the sake of the camera. That's okay. If we have to do it twice, that's why we give them a nice tug, make sure they're secure. And it's going to slide right in to the top of the circuit breaker. There we go, nice and secure. All right, next up, we're going to connect our battery, our UPS to the battery. Get that nice and snug. And get this nice and get this in there. And our neutral for the battery. Nice and snug there. Now I'm going to route this actually behind the DIN rail and into our terminal block. Give it a tug. We're good. Now our UPS module to interface with the batteries comes from the module into the cutoff switch, into the positive terminal block, and then on the negative side, just straight into the negative terminal block to the negative posts on the batteries. Next up, we need to connect our power supply to the UPS module. Make sure these terminals are loosened up. And these are pretty straightforward. And once again, I'm going to route these under the DIN rail. And that just helps keep everything nice and neat. There we are. We get our negative here. Or I shouldn't say negative, it's a return. You always have a load and a return, or battery and return. In our industry, we happen to be building a positive DC system here. We could very easily be working on a negative DC system, in which case our return is positive. We just have to keep that terminology straight. See if I get in there blind. Looks good. And we're going to tighten that down and tighten that down. And one of the things I find useful working on this is a small mirror. Pick that up in an auto parts store. But especially if you're out in the field and you can't see these bottom terminal blocks, see what you're doing, a mirror can help. See if they're open. Why is that wire not going in there? So grab yourself a small mirror, add it to your tool bag, and thank me later. All right. We're going to hook up. I had these wires in there. I'm just making, and they get crimped in different ways depending on what you're sticking them in. So I'm just making sure I got the right wires in the right place. I'm going to hook up our negative, or our return. I keep saying it too. Hook up our return into the common bus here. And return is almost always, I mean, this is an isolated or floating ground, but in most applications, your return will almost always be referenced to ground. So here we'd have positive 48 coming to the return, which is at 0 volts into ground. We could also add a second DC-DC converter to convert the positive to the negative, in which case we'd use a different color terminal block to indicate, but our black, our return, would remain the same. All right. I think this is our last wire we need to actually hook up. Nope. Take that back. We got a few more to do when we put the switch in there. Put that in, give it a tug. We're good. Into the breaker. Give it a tug. We're good. And I struggled with this one when I first put this together. Let's see if we get it on the first try this time. There we go. Doing this on video gives me a new respect for the folks that are building computers or doing other assemblies on YouTube, and it makes me wonder how many times did they have to tear everything apart and start over. This is my second time through, and hopefully I nail it. Oh, I am using a piece of black wire. This is not going to show up on the screen, but I do have green tape on here. It's a dark green. We're going to use this for our ground. So don't sweat that too much. Should have green wire, but we don't. Go ahead and get that locked in. And now we're ready to mount our equipment. And so, not a huge fan of these banana plugs, but they get the job done. Get our battery, which in this case is our positive. Get our return. And the atomic switches have a ground lug right here next to the power input. So just put a ring terminal up on there and get it locked down. Now, a couple things you might want to check before you power this on, if I can find it. Get your multimeter out and put it onto a continuity test. And what we're looking for is this on the netonic switch. This is going to provide, the ground is already referenced to the negative or the return. So if we do any continuity check to any point on the cabinet, any piece of metal anywhere that's not exposed, or that I should say that has mechanical contact with the chassis, should be grounded. But our positive should not. And right now, oh, I got my breaker on. So no continuity, no continuity. We turn the breaker on, and we do have continuity. Look at that. We have continuity there, but not on the battery. And that's because the UPS module will not fire up until it receives good DC on the DC side. You can cheat that by temporarily by bridging the battery plus to the DC plus. Will kickstart that so you can work on it out in the field, get everything running off battery. But here on our battery, still no continuity. All right, so let's turn our breakers off, and we'll go ahead and plug this in and see what it does. And our power supply fires right up. And let's check the voltage, output voltage on it. And we are already set at 28 volts. This is adjustable. It's got quite a wide range. For battery charging and maintenance, you need that to be at least 28 volts. You don't want to max it out at like 20, almost 29 volts. 28 is a great voltage to charge and float your batteries. Speaking of, I guess we should hook up our batteries before we turn those on. Batteries go installed in pairs. There's an inline fuse, and that is used to protect from overcurrent. So if we draw too much juice from here, these fuses will blow, and thereby protecting the batteries themselves and the entire system that we're running here. So let's go ahead and hook these. Oh. And I'm going to set these batteries in here this way up for the sake of the video. There's our negatives or returns. That's black to black. Then our positives is red to red. So two batteries in series giving us 24 volts at 9 amp hours, 24 volts at 9 amp hours. Gives us a total 24 volts at about 18 amp hours. And that'll give us some good runtime in here. We can double check our battery voltages right here. This negative to positive. And we are at 26.63 volts. So these batteries are fully charged and ready to go. We'll connect our batteries by flipping the switch, check our voltage again, and this is now at 27.96. So the voltage is a little bit higher, a little bit lower than what the power supply is putting out, a little bit higher than what the batteries are at already, which means they're floating. All right, last thing we can do is turn on our load. This switch will fire up. And the tonic switches do take about 15 to 30 seconds to power on for some reason. I'm not sure why. That would be a question for another time. So the switch is powered up and we are good to go. Now, a couple notes on these cabinets. We got some cable glands. This large one here, I've actually got one that's one size bigger than this. I think this is 40 millimeters, so about an inch and a half. Maybe this is the 1 inch, and the other one was the 40. This will hold about 12 Ethernet cables, and that's the stranded, shielded, flooded, good stuff. This next size down, the smaller one, only holds about 5. And this one here is even smaller. It holds 3. You might be able to stuff 4 in there. So choose your cable gland based on what you got going on. These that hold 5 are probably a good way to go, because you can just put 2 of them in there, get up to 10 cables. If you absolutely know for sure you're going to have a dozen cables coming in and out, go ahead with the larger cable gland and just drill your hole down here. You can route your Ethernet cables right up and over. Yeah, it's near the AC, but a short time next to the AC power is not going to induce that much of a noise load on it. And so there's our cabinet. I hope you found this informative. I hope I did everything correctly. Like I said, I probably still need to bond to ground from the UPS module down to my grounding block, possibly even down here to the ground lug that is included with the cabinet, just to make sure everything has a good solid ground. You cannot have too much grounding. Hopefully you found this informative. If you have any questions or comments, please do ask. I'm more than happy to answer. I'm also more than happy to be wrong. If I did something incorrectly here, please let me know so that I can address that. And if it's a serious problem, go back and fix that in the units we've already got installed in the field. All right, thank you for watching.